Okay, let's take a look at example 2. It's basically the same sort of thing. We have a transformation of an exponential function. This time out, okay, we are going to do a mapping notation again, but let's remember that we are now translating a different exponential function. Okay, this one has a base value of 2, so we are translating the y is equal to 2 to the x this time, so a little bit different. And then if we put in our mapping notation, it doesn't look like anything is happening to the x. There's nothing in front or after that x, it's just by itself. So the x's don't change at all. And then the outside parts, the y values, are the negative 1/2, the vertical stretch of 1/2, and the reflection around the x-axis. So if your graph reflects around the x-axis, you can expect that it's going to be on the bottom part of the graph this time. We'll see that come up real soon. And then we also said that we can identify the horizontal asymptote right away. So I know, without even sketching this graph, I know that the horizontal asymptote is at y is equal to 5. Okay, so once again, all right, what we need to do is we need to do a table of values for the original graph first. In this table, the y values are going to be different each time. We always use these same 5 x values from -2 to +2. But this time when I put it into y is equal to 2 to the x instead of 3, I'm going to get a different set of values for y. And it's going to look something like this. And once again, for those fractions, you can use decimals if you like. Then we're going to put those into the mapping notation to get 5 new points. The x's are not going to change at all because in the mapping notation it's just x. But in the mapping notation for y's, you have fractions already for 2 of those 5 y values. And in the mapping notation you also have a fraction. You can change that to a decimal if you wish as well. And what you're going to end up having here is you're going to end up getting these y values, whether you use fractions or decimals, okay, it's all going to be basically the same. And we're going to end up having these numbers right here. Okay, check that out right there. Okay, those are the 5 y values that you can get, and like I said, change your fractions to decimals if that helps out. And from there, okay, what we can do is we can start to sketch this graph, a rough sketch of the graph. We already know from our mapping notation that there is a horizontal asymptote at y is equal to -5. And then as we go, okay, you can see here that we can plug in some more points, 2, -7, 1, -6, and so on. Okay, you're going to wind up with a graph that looks like this right here. That's a rough sketch of the graph. Let's go to Desmos and get a better picture of what we're referring to right here. This is it right here. And once again, okay, if you choose to, all right, you can kind of see that the asymptote should be y is equal to -5. If you want to type it in and then hold down on this to make a dashed line, you can see right here that yes, that asymptote looks correct. Okay, next up, all right, what we're going to do is we're going to get the domain and range and the y-intercept, which is at -5.5. So first of all, the y-intercept is already one of the 5 points that we calculated. So you don't actually have to solve for it, but you could go into your equation, put in 0 for x, do your order of operations, and you'll get that point anyway. Then we can take a look at doing our domain. Well, that's the same for all of these exponential functions. And then our range, in this case right here, is a little bit different. This time out, okay, because everything is below the asymptote, you can see that the negative infinity is the lowest bound. Okay, it goes down to negative infinity. It doesn't stop. But the upper bound is at a -5. Once again, it's an asymptote, so we use a round bracket. And once again, also, there is no x-intercept. But to solve for x-intercepts, you're going to need to use logarithms, which is the next unit. So we're going to hold off on x-intercepts anyway until we return to those in the next unit in 12a when we do logarithms.